Hello again, this is Relays and Things, and here is my robot. So this is actually a biped, it's supposed to be a humanoid walking robot. It does have arms, they're here. This is supposed to be its hand area, and they mount up here. So you have the robot, here's its arms. But I didn't mount these because I don't have motors for them yet. But what I do have motors for is back here. This gives it the walking motion. This swings back and forth, shifting its body weight from side to side. In addition to that, this robot is supposed to have motors on all of its legs. But we don't really have that yet. We just have motors on this one leg. But I don't have the motors for the other legs yet, though all of them are still hooked up. So in place of hooking up the motors, I just lock these in place by adding an extra bolt to all the corners. I added an extra bolt to all of the corners on the legs, so the legs are just mounted like this, and when I turn it on, this swings back and forth, and the leg goes up and down. See, it forms a parallelogram here, so when this point and this point are extended, as they are in that one, it moves up and down and side to side. I'm going to put more of them here when I get more motors. These are actually, if you can see, these are actually cordless drill motors from a cheap cordless drill. The wiring job is not finalized. This is just for testing. You would need thicker gauge wire to run two cordless drill motors, but we are using 5 volts here at maximum. So these do go a lot slower considering that they are 18 volt motors. And for combat robots, they are often used at a higher voltage. Looking here is the control system. It's pretty messy, but basically what happens is there are 2 relays here, and this big thing turns the relays on and off, and that makes the robot switch from side to side. So how this works is it's a bunch of Lego motors, and when I turn on the Lego motor, it turns this switch on and off continuously. So let's look at that. So there's gears at the bottom, and the switch goes on and off, on and off, on and off, until it's not doing that anymore. Yeah, wire got stuck inside of the. So let's just take that out. We are actually going to test this. So here's the power supply. This is a computer power supply with the simple green wire mod. There's a green wire and a black wire going to the switch. 3.3 volts, 5 volts, 12 volts, and ground. 12 volts is used to power the relays, while 5 volts is powering the motors. So let's turn this on and let's watch it walk. So to turn it on, first, how I like to do it is you got to turn on the switch first, because if you don't do that, then this motor and this motor will continue to go in circles and the robot will fall down. So that's a bad thing to do. So make sure it's clear of all wires, and then turn this on, and turn this on. Here's it going. Back and forth, and this one goes too. Let's look at the feet. You can see this is a very early design. If it walks, it doesn't walk very much at all. But it does. It is spinning around a lot, actually. It almost fell down though. this up and put this back in place. Okay, so I turn this off. What appears to be happening is the leg where the motor isn't actually, it appears to be bending. So let's fix that now. Once we have actual final designs for the motors and we build them, we will have a way for it to mount. But right now, it's actually pretty loose here. So this is not by any means a final design. Yeah, it just keeps twisting. This could be for a lot of reasons, but it mostly has to do with the bolts not being tightened. So we have our robot right here. I've been designing this robot for over a year. The structure is mainly complete, but it doesn't really want to walk. So let's loosen up this screw to make it. If you wanted to make a walking robot, maybe I would suggest finishing up all the parts first, but we're going to test it incomplete because sometimes it works. This is using the system with the switch. We should get a microcontroller in here actually to have a better system. So okay, here it is again. Let's try to walk. For a marker, it's going to spin around this way, but let's use that as a marker. So as you can see, it does kind of walk actually. So very slowly. So it's walking this way, that way, at an angle. But it is walking. Try it again. And yep, it's got it stuck again.